Now we move to solving problems. The first problem is an urn contains 5 red, 10 green, 8 yellow, and 7 white balls. Of course, the total number of balls is 30. If one ball is selected at random, find the following probabilities. What is the probability that the ball selected is either red or white? Here, as you can see, we have mutually exclusive events. So, a ball that is red cannot be green, or a ball that is yellow cannot be green or red or white. Therefore, we have events that are mutually exclusive. Now, let's solve this problem. Part A, what is the probability that the ball selected is either red or white? So here we're talking about, of course, the addition rule. Okay? So this is solving problem number 1. Solution. Problem 1. A, of course, probability either red or white. Red R stands for red and W stands for white. It's going to be equal probability of red plus probability of white, which is equal, we have 5 red over the total, which is 30, of course, 5, 15, and 15 will be 30. We got 5 over 30 plus white, we have 7 white over 30. We get 30 over 5, 12. We come up with 6265. Therefore, we have 2 fit. Okay, so the probability of red or white is going to be equal 2 over 5. B, what is the probability that the selected ball is neither green nor yellow? So here we're talking about the complement. Okay, so probability of neither green nor yellow. Well, G is green, stands for green, and Y stands for yellow. It's equal 1 minus probability of green or yellow, which is equal, probability of green is going to be equal 10. 10 over 30 plus, because probability of green or yellow is going to be equal, this is the special rule of addition, so it's equal probability of green plus probability of yellow. Plus probability of yellow. Yellow we have how many? We have 8. 8 over 30. We come up with 30, 18 over 30, which is equal 18 over 30. So we're going to have here, let me just, we have 1 minus probability of green plus probability of yellow, which is equal 1 minus probability of green is equal 10 over 30 plus probability of yellow is 8 over 30, which is equal 1 minus 18, which is equal 1 minus 18 over 30, of course, it's going to be equal 3 over 5, which is equal 1 minus 3 over 5, which is equal 5, 5, which is equal 5, 5 minus 3, which is equal 2/5. So the answer is 2/5. The probability that is neither green nor yellow is equal to 2/5. Now let's move to problem 2. Let me erase the answer over here. Let me erase the problem first here, and we solve the second problem here, up here. The problem says solution of problem 2. A vending machine contains 6 7-Ups cans, 10 Pepsi cans, and 4 Coke cans. The total number of cans in the vending machine is 20. Okay? Now, we need to calculate the following probabilities. A, the probability that the selected can from the machine is 7-Up. So, probability 7-Up is equal, how many, 7-Ups do we have? 6. 6 over 20. B, the probability that the selected can from the machine is not 7-Up. So probability not 7-Up is equal 1 minus probability 7-Up, which is equal 1 minus 6 over 20, which is equal 20 minus 6, which is equal 14 over 20, which is equal 7 over 10. Okay, this is the probability of not 7-Up. C, the probability that the selected can from the machine is not, we get this one. C, the probability that the selected can from the machine is Pepsi or Coke. Probability of Pepsi or Coke is equal, of course, the can is either Pepsi or Coke. Therefore, the events are mutually exclusive. So we have to use the special rule of addition. So it says probability of Pepsi or Coke is equal probability of Pepsi plus probability of Coke, which is equal probability of Pepsi. We have 10 Pepsi, 10 over 20, plus probability of Coke, we have 4 Coke, 4 over 20, which is equal 14 over 20, which is equal 7 over 10. Okay? D, find the probability that the selected can will be 7-Up or Pepsi or Coke. Here we're talking about 3 events. Of course, they are mutually exclusive. and we need to use the special rule of addition. Okay, so probability of Pepsi will be 7 up, or Pepsi or Coke is equal probability of 7 up plus probability of Pepsi plus probability of Coke, which is equal probability of 7 up. We have 7 up, 6 over 20 plus we have Pepsi, we have 10 Pepsi, 10 over 20 plus we have 4 Coke, 4 over 20. And this will give us 20 common over 6 plus 10 plus 4. So we get 20 over 20, which is equal 1. So the probability of 7 up that the selected can would be 7 up or Pepsi or Coke is going to equal 1, which means probability is equal 1 is certain to take place. Okay, now we move to problem 3. Problem 3 says a box contains 6 red shoes and 4 black shoes for a total of 10 shoes. Consider the following questions. A, say that 2 shoes were selected at random without replacement, without returning them. What is the probability that both shoes will be red? Here we are talking about, the multiplication rules, the general multiplication rules, because the events here are dependent. Okay, the events here are dependent because we did not, replace or return the, shoes once they were selected. Therefore, we're talking about, events that are dependent. They are not independent, they are dependent. So we have to use the general rule of multiplication, which says the probability of both occurring is equal to the multiplication of their individual probabilities. So A probability both are red is equal probability red times probability of red. Okay? That both shoes will be red. If probability of red times probability of red, which is equal, of course, probability of red, we have 6. The total number is 10. We have 6 over 10 times, because without replacement, then the total number of shoes has decreased by 1. Therefore, talking about, 5 over 9, which is equal 30 over 90, which is equal 1 over 3, which is equal 1/3. Okay? Okay, now part B of the question says, what is the probability that the first shoe selected is red and the second shoe is black, given that the selection of the 2 shoes is without replacement? Still without replacement, that is without returning the the shoes once they were selected. Now, here we have to use the general rule of multiplication, since the events are dependent. Okay, therefore, part B, we say probability of red and black. Is equal probability of red times probability of black, which is equal probability of red. Of course, we have 6 red over 10 times because we are selecting without replacement. Then once we select the first shoe, of course, and we do not replace it, therefore the number of shoes inside the box will be decreased by 1. Therefore, the probability of black will be 4 over 9, which is equal 24 over 90. Now, part C says, what are the answers to parts A and B if the selection of the two shoes is with replacement? That is, you select a shoe, you look at it, and then you return it back to the box. So here, of course, the answers will be different, because in parts A and B, we use the general rule of multiplication because the events are dependent. However, parts A and B, when the selection is with replacement, becomes, we use, of course, in this case, once the selection is, with replacement, then we use the, not the general rule of, multiplication, but we use the special rule of multiplication, because in the special rule of multiplication, the events independent. The events are independent. Therefore, the question will be as follows. Probability of both shoes will be red. Probability of red and red is going to be equal probability of red times probability of red, which is equal probability of red. Of course, we select here in this case with replacement, we select if the first shoe, we look at it, and then we return it back to the box. Okay, in the first case without replacement, we select a shoe and we did not return it back to the box. Therefore, we use here the general rule of multiplication. However, once the selection is with replacement, we're gonna use the special rule of multiplication, of course, because the events will be independent. So here, the probability of red, of course, is gonna be equal 6 over 10 times 6 over 10, which is equal, of course, 36 over 100. This is, of course, C A, part A. Now, C part B is going to be equal. C part B, what is the probability that the first shoe selected is red and the second shoe is black, given that, of course, the selection of the two shoes is with replacement. So here we say probability the first shoe is red, and black, it's going to be equal probability of red times probability of black. So it's going to be equal, probability of red is going to be 6/10 times 4/10, which is equal 24/100. So this is the answer of part B when the selection is with replacement, of course, because once we do with replacement, it means we select a shoe, we look at it, and then we, return it back to the box. Okay, now we move to solve problem 4. Problem 4 says that given the probability that an individual has a car is 0.5, 50%, and the probability that he has a bicycle is 0.8, which is 80%. The probability that he has a car and a bicycle is 0.60. The joint probability of having a car and a bicycle is 0.60, which is 60%. Now, say that A is the event that the individual has a car. So let's say A is the event that the individual has a car, and B is the event that the individual has a bicycle. Consider the following questions. Are events A and B mutually exclusive? Explain. Now, we can say here, because there is overlapping of these two events, okay, because the individual has both a car and a bicycle, so there is some overlapping between events A, which is owning a car, and B, which is owning or having a bicycle. Since there is an intersection between the events, then we say that the events are not mutually exclusive. Okay, so now we say A, answer here. A, the events are not mutually exclusive because there is an intersection between them. Okay, we have an overlapping between the two events because the probability of having a car and a bicycle is 0.80. Therefore, once we draw the Venn diagram later on, we will see the intersection. So once there is an overlapping between the events, then we say that the events are not mutually exclusive. B, which rule of addition shall we use? Of course, because the events are not mutually exclusive, then we shall use the general rule of addition. Use the general rule of addition. Because this rule requires that the events be not mutually exclusive. Okay? Now, part C says, what is the probability that the individual has a car or a bicycle? So here we have to use the general rule of addition to solve this problem. So probability of a car or a bicycle is equal probability of a car plus probability of a bicycle minus probability of a car and a bicycle minus probability of a car and a bicycle. So which is equal, probability of a car is 0.5 plus probability of a bicycle is 0.80 minus probability of a car and a bicycle is 0.60, which is equal, so we get here 1.3 minus 0.6 becomes 0.70. Okay? 0.5 plus 0.8 minus 0.60, of course, 0.70. So the probability of, of the individual having a car or a bicycle is equal 0.70. Now, part D says draw a Venn diagram representing the events in the question. Of course, we have here, some overlapping between the events. Therefore, to draw a Venn diagram, we have to draw first a rectangle, okay? And then we draw the events as circle areas, okay, inside the rectangle. And we show the circle areas, we show an overlapping between the circles to show that, there is an intersection, and to show that they are not, mutually exclusive. So let me erase, the answers A and B and C so that we have enough space to draw the Venn diagram. Okay. Now, answer D. So to draw a Venn diagram, we first draw the rectangle. This is Venn diagram. This Venn diagram represents the outcomes of all the outcomes that are included in the sample space. This is here sample space, S, where S is a sample space. And the probability of S equal 1. You can say here, probability of S equal 1. Okay? Now, we need to draw the, of course, the outcomes here. Okay? Now, we draw the first one, A, the event A. Remember here, event A, which is the event A is the case where the individual has a car, and it is the probability of that event is 0.5, and B is the event that the individual has a bicycle, and the probability of bicycle is 0.80. So you can see that the circle of B should be bigger than the circle of A, because the probability of B is 0.80 and the probability of A is 0.5. So we have to show that here. So this is here, what you see. This is A, which is here probability of A, which is equal 0.5. Then we have to draw this one here. This is, let me just make it larger here. This is B. This is probability of B, which is 0.80. Now, the intersection here is, of course, is 0.60. This is here, 0.60. This is the intersection between them. Okay? So we have an overlapping between A and B. A and B, the intersection here is 0.60. This is how we draw the events when there is an overlapping between them. Okay? Here, the event diagram, and inside the event diagram, we draw the events A and B, where the size of the circular area of B is bigger than the size of the circular area of A, because event B is 0.80, the probability of it, and the event A, it is 0.5, because the probability of it is 0.5. And this is the intersection between them, which is 0.60. Okay, now we move to solving problem 5. Problem 5 talks about a contingency table. It says, consider the following contingency table that shows a group of 100 students by gender and class. So you have gender here and class. This contingency table, of course, is kind of a catalog that cross-tabulate the observations, the gender along the, of course, the column, and the class along the row, of course. So as you can see, the males, we have 30 freshmen, 20 sophomore, 10 junior, and nothing here in senior. So we have to fill out those spaces, of course. Of course, as you can see, we have 4 levels of students when he is in the undergraduate level. The student, the first year in college is the freshman year. The second year is called sophomore year. The third year is called, of course, junior year. And the fourth year is senior year. So now we have all the data here, except, some, spaces are missing. We have to, look at the questions to see exactly what is needed to do. Now look over here. Do the following questions. First, A, fill out the missing space, space in the table above. The missing spaces in the, of course, table above. Now, of course, freshmen, we have 30 males. The total of freshmen 45, so we should have females 15, because the total here 45. Now, come over here, senior, we have the total 10, so we should have 5 over here. Okay? So here we fill out the table. Now, part B, find the probability that randomly selected students. So we select a student randomly from this contingency table. Now we need to find the probability that this selected student is a female. So we look over here. A female, of course. Female, of course, we get how many females do we have? If we sum all of those, we come up with 35. So we have B B, of course, find the probability that this selected student is a female. We have 35 females. The total is 35. So we have probability of female is equal 35 over 100. This is the probability. Of course, we left it as a fraction because it is valid to leave the probability either a fraction or a decimal. B, what is the probability that this selected student is a sophomore? So we look over here, sophomore, that's sophomore. How many sophomore do we have? We have 30. So C, probability of a sophomore is equal sophomore 30 over the total number is 100. Total number of students is 100. Now, D, find the probability that this randomly selected student is a male or a junior. This is B here. And this is A, this is B, and this is, of course, هنا so we get A, of course, B, or female, C, probability of sophomore, and D, a male or a junior. A male or a junior. Now, as you can see here, we use, of course, the general rule of addition, because the events here are not mutually exclusive, okay? Because students can be a male or can be a junior at the same time. Therefore, we use the general rule of addition. So here, D, probability of male or a junior is equal probability of male plus probability of junior minus probability of male and junior. So probability of male or a junior is equal probability of male plus probability of junior minus probability of male and junior. Okay? Clear? So what is equal? Probability of male, as you can see, we have 65. 65 over 100 plus probability of a junior, as you can see, junior 15. 15 over 100 minus probability of male and junior here 10. As you can see, the intersection male and junior is 10. So we have minus 10 over 100. So we solve this one here, get 100. We get 65 plus 15 minus 10, which is equal 70 over 100. 70 over 100. Okay? This is D. Now, let me erase first here and solve part E. Part E says the probability of a male and a female. A male and a female. As you can see here, those don't intersect. This is the joint probability, but we don't have, any, a person or a student cannot be male and female at the same time. Therefore, the probability of a male and a female is 0. Probability of male and female is equal 7. It's equal 0, of course. Therefore, here we don't have, there is, no intersection between them. Probability of male and female, it's impossible to have students who is male and female at the same time. Therefore, the probability is 0.